Elmo Application Studio Tutorials. These three. Welcome to the Elmo Application Studio tutorial. This lesson will review how to tune an Elmo servo drive. Select System Configuration from the main menu. In the workspace, choose your drive type. Select the connection type. Choose the appropriate port and click Connect. A red light will indicate a successful connection. Select Drive Setup in Motion. Choose the Expert Tuning tool. Elmo's tuning process follows a clear flow. Define system parameters, identify system dynamics, tune the controller for optimal performance, and verify results before saving to ensure reliable operation. Fill in your axis configuration parameters. Here you can view the electromechanical configuration options. In this example, we will demonstrate the rotary motor rotary load configuration. Fill in your motor settings. Select the motor type from the available list and fill in all the motor details, including the last four values: resistance, inductance, back EMF, and torque constant. It's preferable to fill them in, but if you don't have these values, don't worry. These will automatically calculate and estimate the values as we go through the tuning process. Fill in the encoder details and the port to which it is assigned. Enter the User Units tab to select the units you want ease to display. You can define the drive's current limits. Note that the drive's current limits are given in amplitude current units, while in the motor settings, the values are set in RMS units. If required, set up motion limits. You can configure the optional built-in protections and choose drive stopping options. The Expert Tuning contains a variety of options that may be useful for specific applications, such as defining the settling windows and setting the logic level and functionality for each input and output. You can also define a filter for each input. Run identification on one or all motor phases. Choose the current level percentage of the peak current. Note that the motor is about to move. Here we can see the Bode plot for the three motor phases and the calculated resistance and inductance of each phase. Set the required bandwidth and phase margin, then click Design. Adjust KP and KI or refine the design as needed. Click Verify to run a step input and measure the response. Choose the desired auto-phasing method. Set the experiment's current level, displacement and velocity, then click Run Commutation. Please note that the motor will move during the commutation. The commutation process starts by defining the motor's positive direction for all feedback sensors. It aligns commutation sensor readings with motor phases to ensure proper current application. Choose between fast identification and sine sweep identification methods. Select the normal signal band for fast identification and set the experiment's current level. For protection, set the velocity and position error values and run the experiment. View the Bode plot indicating the identified plant's magnitude and phase. There are a variety of plant options available, including velocity plant, position plant, and their corresponding control filters. These options allow users to fine-tune system behavior for open-loop and closed-loop configurations, ensuring optimal performance for specific applications. After tuning the controller, the next step is to verify its performance and adjust the gains to ensure it meets the required specifications. Enable the drive to turn the motor on. Set the values for the motion that you would like to perform. To fine-tune the controller settings, perform a recording of the motion. Choose key signals. Define the trigger. Adjust the controller and view the effects of the new values. Once you have tuned the tuning parameters to meet your performance requirements, stop the recording and the motion. Click the Summary tab and choose to save all the tuning parameter values to the servo drive, as well as create an additional backup on your computer. You can also save your current, velocity, and position plans for later analysis and tuning. Thank you for watching. This tutorial provided an overview of how to tune an Elmo servo drive using ease. Stay tuned for more detailed guides to help you master the full configuration and fine-tuning process.